This is a question of circular motion in which we have been given a ball of mass 0.4 kgs attached to a string of some length moving in a vertical circular path with tangential speed of root 3 meters per second. We have been given the values of sine 60 and cos 60, and we are supposed to find the tension in the string at the shown position. Step number one in solving this question is draw the free body diagram of this particular object. So the first force acting on this object is its own weight mg, and then we have the tension T acting along the string. It's away from the body. Step two is to identify the centripetal force for this particular case. We know the centripetal force is the net force which is acting towards the center. So we can see T is acting towards the center, but one component of mg will also be towards the center. So how do we do it? So resolve the mg into components, and let me draw a dotted line. So this angle is also 60 degrees. So one component of mg will go along this dotted line, and that will be mg cos 60. And the other component, which is perpendicular, will be mg sine 60. So we have T tension going towards the center and mg cos 60 going away from the center. So the net force which acts towards the center, which by definition is the centripetal force, should be T minus mg cos 60. So this is our centripetal force, and we equate that with the centripetal force formula mv square by r. Now, since we are supposed to find the tension in the string, let us make T as the subject from this equation. So we'll get T equals to mg cos 60 plus mv square by r. Now let us put all the values in. The value for mass is 0.4 kilograms. Let's take g as 10, and cos 60 is half. Plus mass again is 0.4. Now the tangential speed was given in the question. It was root 3 meters per second. So we square the root 3 and divide that by the radius. Now radius of the circle is actually the length of the string, which is given as 0.2 meters. Now let's simplify this. So in the first expression, we will get a 2, and in the second expression, we get a 6, which simplifies to 8. And let's have a look at the options. In option B, we can see 8 newtons is there, and that's how we find the tension in the string.